So without further ado, my colleague Dan Ferguson, he is a cloud data architect here at Ippon Technologies USA. He's going to be doing his talk entitled Enforcing Data Quality Management with AWS. It's going to be a lot of good content here for you, and you're going to really like his presentation. So take it away, Dan.
Thank you, John, for that lovely introduction. My name is Dan, and the title of my talk is Enforcing Data Quality Management with AWS, just like John said. A little bit about me. I'm a solutions architect at Ippon. I've been working with AWS for a little over a year now, maybe a year and a half. My background is in messaging, low latency messaging, and event-driven architectures, and that's kind of where the inspiration for this talk comes today, except we're going to be focusing in on AWS and data quality management. So the thesis slide for this talk is that events decouple DQM jobs from ETL jobs. The idea is that these two separate jobs are tightly coupled and events will break them apart. So for those of you that don't know, DQM and ETL are two acronyms used in the data analytics and data engineering space, where DQM stands for data quality management and ETL stands for extract, transform, and load. ETL jobs are common in places where you're trying to move data from location A to location B, and DQM jobs are common when you're trying to make sure that your ETL jobs performed the way you expected them and designed them to perform. It's like a test or a verification. So a little bit of background on event-driven architectures. They tend to have the top four components. Some of them have the bottom two as well. You need a message bus in an event-driven architecture, something that will facilitate the transfer of messages from A to B. And you need a routing protocol, producers, and consumers. The routing protocol can be anything you want. If you're familiar with RabbitMQ, you'll probably know about queues. If you're familiar with topics, you're probably familiar with Kafka. Some message buses use network subnets like or rely on networking protocols like UDP to facilitate messaging. But as long as there's a way to transfer messages over a network, you're good to go. And then you need an event producer and a consumer, something to publish the message and something to consume it on the other side. Typically these days, you'll also have something like a schema registry and an analytics component, where the schema registry will store different types of messages and your analytics component will examine the stream of messages as they're being published or before they're being consumed. These two are not necessary strictly. They do help though. The schema registry will help you have uniformity throughout your event-driven architecture. And streaming analytics is a great way to start having some real-time integrations into your event-driven architecture, real-time monitoring for that matter. So laying all of these components out, you start with the schema registry if you have one. You pull the type of schema for a message you're going to publish. You publish that message over your producer and it goes out to the message bus. The message bus will use the routing protocol that it's been configured to use to get it to the desired consumer, and the consumer will conduct some downstream process based on the contents of the event. If there is some streaming analytics, it's going to happen in step 4 between the message bus and the event consumer. You could have it between the publisher and the bus as well if you want, but that's probably not very helpful. So this is what a general event-driven architecture would look like, or a generalized version of that. And there's a lot of different message buses out there. I mentioned a few before. It doesn't really matter which one you use for this talk, or if you were to try to implement something like this talk in your environment. As long as you have a message bus, that's really all you need. Anything else is pretty arbitrary. You can take the concepts here and apply them to pretty much any message bus out there. So here's the problem statement, right? And I touched on this before in the thesis. ETL and DQM workflows are both inherently stateful. What does that really mean? It means that the ETL jobs and the DQM jobs are tightly coupled. If your ETL job finishes, the output of your ETL job will feed the input of your DQM job. So this effectively creates one long job, but it's two pieces of information that are or it's two goals that each job completes. So you have one long job completing two separate goals. Your ETL job is completing the goal of moving data from A to B, and your DQM job is validating that that data was moved in a correct way. So by breaking these two jobs up, we're removing that stateful coupling of the ETL job and the DQM job so that they can proceed asynchronously and possibly more in an easier to understand environment. So this is what your typical orchestration flow for an ETL job would look like. And this will kind of show why ETL and DQM are coupled so tightly together. Again, this is using AWS as an engine. So your typical ETL job on AWS would have a source database like RDS, a data pipeline job, which would possibly trigger Glue to collect information on S3, dump raw database files into S3, and use EMR to extract, transform, and load data into Redshift. So with the labels, this is kind of the typical components you would see in an ETL workflow. So DQM, how does that fit into this process? So when a DQM job runs, it tries to grab this kind of information from an ETL job. Information about the job itself, information about tasks within the job, information about the parameters sent to the job when it was started, a lot of different information, and really the information you capture is dependent on what kind of data quality you're enforcing. If you just want to know that your job ran, you may not need a separate DQM pipeline to confirm this. But if you want to know when your job ran and how long it ran for, you may want to do that. If you're using something like Airflow to orchestrate these jobs, then it may not be necessary to do that because Airflow has a pretty extensive data quality setup. But depending on your message bus and how your ETL jobs run, you may want to collect this kind of information. This information may be too granular for your use case, or you may want to go more granular. It's really up to you. So assuming we're collecting data like that, this is what your DQM integration into an ETL job might look like. We have the same familiar components, an ETL orchestrator, an ETL job, a source system, a data warehouse, a data catalog, stage storage, but we also have this Lambda and a DQM database. And you'll notice the Lambda is labeled ABC. So what does that really mean? ABC is a framework for implementing DQM. It's one of not too many out there, but ABC stands for Audit, Balance, and Control. And by implementing the ABCs of DQM, you have a really solid framework upon which to impart data quality management on your ETL pipelines. So the A stands for audit, and audit means that you're checking to see if your ETL pipeline performed quantifiably as expected. Assigning numbers to the performance, assigning a rating and a scale to the performance of your ETL pipeline, and measuring that performance against a success or failure criteria. Typically, this will mean something like an SLA, a memory threshold, or a compute threshold, something along those lines. It really depends on what kind of information you need to keep track of. And this is kind of why ETL pipelines are so tightly coupled with DQM pipelines, because not every ETL pipeline may need to track the same audit information. So this is something that is pretty highly dependent on the pipeline itself. B stands for balance, and balance just makes sure that at the beginning and the end of the ETL pipeline, the records you extracted are the same records that you had loaded. This is obviously important no matter what ETL pipeline you're running, no matter what kind of pipeline is being used, no matter what message, no matter what ETL orchestrator you're using, if it's Airflow, if it's data pipeline, it doesn't really matter. you want to know that not only the number of records you extracted is equal to the number of records you loaded, but that the contents of those records are identical in both data systems, taking into account the transformation function that your ETL pipeline has used. You need to know that both systems are the same. And C stands for control. Control means that you can respond to issues in your ETL pipeline automatically. This is kind of a very elegant way of saying automatic issue resolution. You can have your DQM pipelines publish, for example, publish some input parameters to start an ETL job that would extract a subset of keys from a very specific data source, and then run them through a predefined pipeline to load them into your data warehouse. So when your balance job and your audit job have completed, you can potentially run a control job to fix any issues that audit or balance have identified. So this would be a sample audit process. This is very highly dependent on the ETL job that you have. So I'm kind of running, kind of riffing here, but you would have your sample source system and your destination system. And you would have a Lambda that checks to see if the job ran in the expected amount of time. If there was a number of records that you expected to have pulled and that record count was met. And then you can record that information in a database somewhere like DynamoDB. DynamoDB is a great choice because if you have dozens of different ETL pipelines, all with different audit requirements, you can just drop whatever information you need to keep per pipeline in DynamoDB in the same table without having to worry too much about some of the database constraints that you would normally have when writing to a database. This would be a sample balance process. In this situation, I've shown that you pull balance queries from S3 and run those queries against RDS, and which would be your source system, and Redshift, which would be your destination system, and use Lambda to make sure that the contents of those queries are identical. Storing queries in S3 may be a little naive, but it does lead to the idea that you can store files that would show you what a properly balanced system would look like. For an ETL pipeline, you can store a query on one table and a query on another table, and taking into account the transformation that happens, you can supply your Lambda with information on how to tell if a pipeline truly created a balanced downstream database in Redshift. And then you can store those results in DynamoDB the same you did for your audit results. And a control process is pretty straightforward. You would take the inputs from DynamoDB after the balance and audit jobs have run, and potentially, if something is wrong, if the ETL job did not run as you expected, you could publish instructions to rerun the data pipeline job with the parameters that you've extrapolated from the data in DynamoDB. This will let you rerun the data pipeline job as if it were a brand new job, and it can run completely independent of your DQM job. Your DQM job is now over, and you've recorded the information in DynamoDB, and now your ETL pipeline is running as just a separate job. You don't have to worry about it anymore, and it will kick off the same DQM process as a separate process later on downstream. So when I talk about event-based DQM integration with ETL, this is kind of what I'm talking about. In generalized architecture, again, using AWS services, you have your data pipeline writing to your EMR job. Your EMR job will pull records from your source system into a destination system. You have your stage storage in S3 and a data catalog. You have your Lambdas performing ABC functions, writing to DynamoDB, but you also have that bottom row there. That's a message bus. In this case, in this architecture, I'm showing that SNS is being used, writing to SQS, and you have some step function that would pull from SQS and start an ABC job after, given the information that's coming from the data pipeline. Doesn't have to be SNS or SQS. It could be Kafka. It could be RabbitMQ. It could be EventBridge. Actually, in the demo, it's going to be EventBridge. So it could be whatever you want it to be. I would recommend you kind of think carefully about the data quality you want to impart, though, before choosing your message bus. And we'll get into that later. So this is kind of what a sample event would look like. Again, this is all pretty open-ended because it really depends heavily on the system you're trying to impart data quality on. But this is kind of a sample that takes all the different topics I've talked about and puts them in the same event. Notice you have a job ID, you have an array of task IDs, a mapping of parameters, the number of records written and the number of records read. Notice that written records is one shy of the number of records read, so it means somewhere a record's been missing. This is not a balanced system. You know where the source statement of record is, and you know where the destination is as well. Technically, in this case, we have a staging area in S3, but that doesn't necessarily need to be there. Depends on your system. You could, for example, replace a staging area with a glue dictionary if you wanted to do some business logic validation. You have balance fields in case you want to balance the values of different specific fields in your source and destination systems, not necessarily the entire record. Where your balance queries could be stored and where your logs could be stored in case you want to do log analysis on your ETL jobs to get some audit and balance information. It's heavily up to you and what your situation requires. The really cool thing about ETL or DQM orchestration using events is that you can run these events sequentially or serially. And I'll get to that in a minute, but on the right here, you can see this diagram that I created using Solus Cloud. Solus created this really cool event mesh, and the Solus is a hardware vendor that sells event buses. They've pivoted in the last year or two into the cloud, and they have an AMI on Amazon for EC2 instances that you could spin up in your AWS environment, and it'll act as a message bus. And in this situation here, I'm using their event mesh diagram builder, which is available on console.solus.cloud, to show that you can create these event-based architectures using software, not just Visio. And you can see here that your ETL orchestrator publishes several messages in the serial layout. It'll publish a ready for audit, ready for balance, ready for control message. And this can happen whenever you decide. It depends on the ETL pipeline itself. As long as you want it to publish at a certain time, you can have it publish whenever you want it to. It's just it could potentially be as simple as an API call. Or you can have your audit app, your balance app, and your control app publish the messages to the next application down the chain as you see fit. This is really a cool way to break up your audit, balance, and control apps into smaller and smaller components. Depends on your infrastructure though and what you're looking to do. If you want one big component to manage DQM, then you may just want one event between your ETL orchestrator and your DQM orchestrator. All that matters is at the end, you aggregate the results in that DQM aggregator you see in the center there, which publishes results to some downstream process that can be used for analytics, that can be used on a dashboard. It can be used to show stakeholders that something is working as expected or not working as expected, and why. So I touched on the different strategies of orchestrating DQM tasks before. This may be an easier way to see that. In the top, we have serial orchestration, where you orchestrate whenever you want, in whatever order you want. Here I'm showing that the audit process will run between extract and transform between transform and load, we're calling balance and control. That's totally up to your discretion whenever you want that to happen. By far the easiest way of doing this though is to just have a sequential orchestration, where extract, transform, and load process is done, it calls or it publishes an event that calls audit balance and control. This way you don't have disparate components of your DQM job running or waiting for an upstream process to finish. It's a lot less to orchestrate and a lot less to manage, and it kind of falls in line with the concept that I'm trying to promote in this talk, is that events break up these two components. If you do the serial orchestration, then you still have to do, you have a lot of other work to do to enforce that, enforce the breaking up of ETL pipelines and DQM pipelines. But it's not impossible, and it is pretty open-ended if that is something you want to do. It's just something you'll have to keep on top of, especially as your ETL pipelines scale and change and develop with your business. So what are some pitfalls to look out for when you're doing this? You have to make sure you pick a message bus that is as reliable as your DQM jobs need to be. If you don't pick a message bus with an uptime that is acceptable, or at least a recovery point objective that is acceptable, then your DQM jobs will suffer. And the last thing you want to do now is go back and trace through events that should have been published and jobs that should have run when you don't even have that information to go reference. Another thing to worry about is event schema compatibility. If you do something like Confluence schema registry, you should be okay because their schemas are pretty forward and backward compatible. But if you change message buses and you're no longer using a schema, or you change a schema registry to something in-house, you have to make sure that your publishers and consumers are aware of the different schema changes that happen. Another thing to keep aware of is event subscriber uptime. In this demo and in the architecture diagrams in this presentation, I'm showing that lambdas are the typical consumer, but they time out after 15 minutes. So if you don't have something that triggers lambdas, then you're gonna have to constantly be turning on and off, constantly be running lambdas as soon as they're on and off, which is just as effective as keeping an EC2 instance up and running at all times. So make sure you pick the kind of subscriber that you want to match your event bus. In my demo, I'm using Event Bridge. An Event Bridge will trigger events will trigger downstream processes based on the events that happen. That's the protocol it uses. So Lambda fits pretty well with that. But if you use something like Kafka, you need a message bus, or you need a consumer that will read off of the event log and fire off a downstream process that way. So lambdas would not work in that situation. The last thing to always keep in mind is that ETL outputs are DQM inputs. If you want to run your DQM jobs like in a serial orchestration, you need to make sure that all of the outputs for every component of your DQM job are available before you run them. So that's why I recommend the sequential orchestration of your DQM jobs, because you're guaranteed to always have those outputs ready for your DQM job after the load component has been completed. So it's something to keep in mind that you may not always want that, but it is an important thing to remember as your DQM jobs scale, as your ETL jobs scale, and as your data warehousing needs scale as well. So why would you do this? What does this give you? Down the road, potentially, you could implement the following things. You could start putting CloudWatch alerts on your pipelines, especially if you're hosting everything on AWS. CloudWatch is a great way to start giving you more insight into your ETL jobs. I know Airflow is a pretty common orchestrator for ETL jobs, but there isn't too much that's done out of the box in terms of monitoring. There's a lot that has to happen behind the scenes to hook up your monitoring system with Airflow. And then you get some insight into how your ETL jobs are running. Now, if you're doing everything on AWS, you could just use CloudWatch, and now you have some insight into if a Lambda fired, if a Lambda did not fire when it was supposed to fire, and you can create dashboards off of this. Dashboards are a great way to maintain operational excellence. as AWS calls it. And you can use QuickSight, which is a great service for dashboarding your CloudWatch alerts, dashboarding log data against Athena or S3, depending on where you store log data for your DQM jobs. Always keep that in mind, that if you want to log information, you want to log it to be useful down the line, like in a phase 2 next step, where you would set up a QuickSight dashboard to show you those logs without having to find them yourself. Another thing you could do is you could put an API on top of your DQM jobs. This is kind of like giving the user the ability, or an end user the ability, to publish messages themselves. It also creates the ability to reliably deploy DQM infrastructure behind an API without having to worry about if your DQM infrastructure is down. Having an API will keep things reliable. And then possibly deploying some real-time analytics on top of your message bus. The only solution I know of that this works really well with is in Kafka. If Kafka is your message bus, you can use KSQL. Kinesis also has an analytics component that will let you do real-time analytics if that's necessary. I wouldn't recommend this though, because this is for highly low latency real-time streaming data, and DQM is probably not that. The same for ETL. ETL typically implies that you know where the data is coming from and you just putting it someplace else to make it more useful. So you're probably well aware of your data. And if you're doing real-time analytics on metadata about your data extraction and loading, you probably have a lot more time on your hands than most people. So it may not be necessary or even worthwhile to impart real-time analytics on your DQM jobs, but it is something that you could do. So the one thing to take away from this is that the concepts I'm talking about are pretty general, and they can apply to any message bus. In the architecture diagrams, I show that SNS is the message bus, and that's probably the easiest out-of-the-box solution to use for an AWS hosted pipeline. There are a bunch of other options. In the demo, I use EventBridge because I like the way it triggers lambdas based on whatever events it receives. Here I say that you can use Kinesis, you can use Solus PubSub, and you can use a AWS managed Kafka service. The decision to use one over the other is really very dependent on your use case. If you have a hybrid cloud solution, you would probably want something like Solus. If you wanted to integrate with several downstream processes or with several downstream services without having to worry about making code changes, you can use Kinesis and Kinesis Firehose. Kafka is great for the message log that it provides. You can always just look at that message log to get a historical audit trail of all messages published. This would be great in case your message bus goes down. Just look at that log when it comes back up. It really does depend on your use case though. There's no right or wrong message bus to use. As long as you have it working so that your DQM jobs run independent of your ETL jobs, that's half the battle right there. So I'm going to go through the demo right now. The architecture was published using AWS CDK. It's on GitHub, and really all it does is I have a publisher lambda that writes an event to EventBridge, and that will trigger a consumer to write to DynamoDB. And then DynamoDB can integrate into whatever downstream process you want. That's pretty open-ended. In my project, I think it's screen sharing is paused, yeah. I'm gonna go to, there we go. So this is the publisher. It's a pretty straightforward publisher. All it does is it looks for an event that's coming over, grabs some messages out of the body, and publishes them over an EventBridge event. So I'm going to copy the message for an audit event. And we'll paste it here. And just to give you some insight into exactly what I'm publishing, this is the body of the message. And in here, I've I'm improvising a little bit, but I'm putting in a source value as my EDQM Airflow hook object. And I'm writing the same number of records read, 10,000. This is an audit message, and these are the resources that have been affected. In this case, it's some sample DAG running on Airflow. So we create this and test. It runs. Now what happens is this is going to go over EventBridge. To this new bus. And in this bus, there are two rules. One rule that triggers on a detail source match, something like this, EDQM Airflow hook, Snowflake hook, or database log writes, if you have log shipping on a database. And the same for detail type. Depending on the detail type, we have an audit, we have a balance, and we have a control. So in this situation, it's going to call the consumer, and the consumer is going to write to a DynamoDB table here. Why does it write twice? Because there's two rules. Two rules that have both been matched on the event that I've sent. And that's kind of an important thing to think about. I tried to hit home the idea that depending on the message bus you pick, you will have different issues to encounter. And this is one of those, this is the same thing. I picked EventBridge, and because of my carelessness, I created duplicate event publishers because I wasn't writing this. Publisher, consumer, or the event bus rules to take advantage of EventBridge the way it's meant to be used. And that's something to keep in mind for every single message bus you choose. Something to pay attention to. So this is the balance event. As you can see, it publishes a sample event on a Snowflake hook, and it publishes this query. Select star from table where this balance condition is like balance me, limit 1, and the expected response that should come back from both sources of record. This is my upstream endpoint, my source, and my downstream endpoint, my destination. And if we run this and test it, you can see that it ran. And I'll just quickly go back to the DynamoDB table. And we can see that we have our balance information there as well. We'll do the last one, control. Copy it really quick. What does our control event do? Whoops, that was the balance one. The balance one says the control event says that there are missing records from this table, this table, and these are the IDs that need to be pulled. We are assuming that this is a pretty simple table structure with just records with primary IDs, primary key IDs at 0001, 0002, and 0003. And that, again, we can maintain a list of URLs for our source of truth, who caused this, where did this issue come from, potentially why it happened, and the identifier for the pipeline that caused this to happen. We create that event, test it, we go over to Dynamo, refresh. There it is. So now we can see our control records have been added as well. So this is all fine and good, but what are you supposed to do with your control records or your audit records or your balance records now that they're in DynamoDB? Technically, what should happen is that you should be acting on them, doing something to rectify the situation. My consumer is the one that's going to be doing this. In this demo, I don't really have anything because I don't want to maintain an AWS build that has a source record or a destination record, destination database. But instead of putting to DynamoDB, you could insert your business logic into the Lambda. Depending on the event that was received, for example, the detail type, notice the detail type here indicates what action is supposed to happen. The detail type could indicate what you're supposed to do next. Now, if this were in a step function, you could route to a separate Lambda for handling audit problems, route to a Lambda for handling balance problems, etc. It's really up to you how you want this to happen. It's a pretty open-ended process. There are no right answers, unfortunately, but that is the nature of ETL and DQM. If there was a right answer for every situation, we wouldn't have all of the resources and tools out there today. These are some references. I can post them in the channel comments if you like. Just some really good sources of information about data quality management and ETL on AWS. And that's that. I think I'm done. Thank you for coming, and I hope this talk helps.
This talk helped a lot. Dan, thank you so much. Excellent words of wisdom, excellent presentation.
Thank you.
I think we all enjoyed it, and hopefully, no, you're welcome. And good job.
Thanks.